Welcome to an enlightening session where we delve into the fascinating world of calculus. This video is a product of artificial intelligence, brought to you by our innovative app and company. Our mission is to simplify complex topics, making them accessible and engaging for everyone. We believe in the power of knowledge and its transformative potential. While we're on the subject of support, we'd like to mention that there are links in the description of this video. These are promotional links that, when clicked, can lead to purchases that help sustain this channel and our work. It's a simple and effective way to show your support, if you choose to do so. We're excited to embark on this journey of discovery with you, exploring the myriad applications of calculus in real-world scenarios. So, buckle up for a ride into the realm of numbers and equations. Don't forget to subscribe, share, like, and comment. Your support helps us create more of this content. Calculus, a fundamental branch of mathematics, often leaves people intrigued and curious. It's a world of change and motion, dealing with everything that moves and grows. Calculus helps us understand how things change, providing a framework to model the real world. It's a tool that breaks down complex systems into understandable parts. Imagine calculus as a magical set of eyeglasses. When you put them on, the world transforms. Suddenly you can see patterns in the way trees grow, the way rivers flow, even the way planets move in their orbits. Calculus is not just theoretical, it's practical and powerful. It's used in physics, engineering, economics, statistics, and many other fields. It helps engineers design bridges, economists interpret market trends, and physicists understand the nature of the universe. Now that we have a basic understanding of calculus, we'll explore its real-world applications. Let's dive into the first real-world application of calculus: physics. Calculus is the backbone of physics, a field where predicting the behavior of moving objects is crucial. Conceptually, it's all about change and motion. Take the fundamental principle of motion, for instance. Newton's second law, force equals mass times acceleration, or F equals sine ma, is a differential equation derived using calculus. It allows us to calculate the future position and velocity of an object if we know its present position, velocity, and the forces acting on it. From predicting the path of planets in our solar system to understanding the behavior of particles in quantum mechanics, calculus is indispensable. It helps physicists to model physical phenomena accurately, making it possible to design everything from bridges to spacecraft. Without calculus, our understanding of the physical world would be significantly limited. So, calculus in physics, isn't it fascinating? Moving on, we find calculus in the field of engineering. Calculus is the backbone of most engineering fields, playing a crucial role in system design, control, and optimization. It helps engineers model and analyze different systems in a quantitative manner. Take, for instance, the formula for calculating the area under a curve: integral calculus. This concept is used in determining the total power output, or work done, by a mechanical system over time. This is vital in designing engines, motors, and other power-generating or consuming devices. Or consider differential calculus, which is used to optimize resources. For example, engineers might use it to determine the most efficient shape for a container, maximizing capacity while minimizing material usage. Calculus is also used in signal processing, fluid dynamics, and even in the design of complex structures like bridges and skyscrapers. From small gadgets to large infrastructures, calculus is essential in making accurate predictions and efficient designs. Calculus and engineering, they go hand in hand. Our next stop on this tour is economics. Now you might be wondering, what does calculus have to do with economics? Well, quite a lot actually. Economists use calculus to model and predict economic phenomena, such as how changes in interest rates can affect the economy. Take the concept of marginal cost, for example. It's the cost of producing one more unit of a good or service. By using calculus, economists can find the derivative of the cost function to determine the marginal cost at any given level of production. And it's not just about cost. Calculus can also help us understand revenue and profit. Economists use calculus to maximize profit by setting the derivative of the profit function equal to zero and solving for the quantity of production. So, you see, calculus is not just for mathematicians or engineers. It's a tool that can help us understand and predict the world around us. Who knew economics and calculus could be such a powerful combination? Calculus also plays a significant role in medicine. You might be surprised to hear this, but calculus is integral in many medical practices. For instance, take the field of medical imaging. When a doctor uses an MRI or a CT scan to diagnose a patient, they're relying on calculus. Here's why. These machines use a series of mathematical algorithms, many of which are based on calculus, to convert the raw data they receive into a usable image. For example, the radon transform, a formula integral to CT scans, is a calculus-based algorithm that takes the raw data from the X-rays and turns it into a clear image a doctor can interpret. By understanding the mathematical principles behind these machines, doctors can better interpret the images they produce, leading to more accurate diagnoses and better patient outcomes. So, calculus isn't just about numbers, it's about saving lives too. Ever wonder how your GPS works so accurately? The answer is, you guessed it, calculus. You see, calculus is the mathematical magic that makes our GPS technology so precise. It's used to calculate the precise distance between you and the satellites in space. This is a complex process that involves determining the time it takes for the signal to travel from the satellite to your GPS device. But how does calculus fit into this, you might ask? Well, it's used to calculate the rate at which the signal travels, taking into account factors like atmospheric interference. This rate, known as the derivative in calculus, is crucial in determining the exact position of your device on Earth. Now let's take a look at a related formula. Consider the derivative of a function f, represented as f prime. This derivative represents the rate at which the function changes, similar to how the GPS signal changes as it travels. Next time you use GPS, remember it's the calculus working behind the scenes. Calculus also finds its application in the world of computer graphics. It's the secret ingredient that helps to create realistic animations and stunning visual effects that we see in movies and video games. To understand how calculus plays a role here, let's take a simple example. When creating a 3D model, we often use something called Bezier curves. These curves are defined by a mathematical formula that involves calculus. It helps in creating smooth and adjustable curves, which are essential for modeling complex shapes and animations. Calculus is also used to calculate lighting and shadows. By using calculus, graphic designers can determine how light will interact with an object and cast shadows, creating a more realistic visual experience. These are just a few examples of how calculus is used in computer graphics. From modeling to lighting, calculus is a fundamental part of the process. Calculus is indeed the unsung hero in the world of computer graphics. Our last real-world application for today's session is in the field of astronomy. Now, we all marvel at the beauty of the night sky, but have you ever thought about the math behind it? That's right, calculus is integral, no pun intended, to our understanding of astronomical phenomena. For instance, when scientists calculate the changing gravitational forces between celestial bodies, or the rate of change in a planet's orbit, they're using calculus. It's also used in determining the brightness of variable stars, or predicting when the next solar eclipse will occur. Let's consider a simple formula that astronomers use, Newton's law of universal gravitation. This formula, F equals g times m1 times m2, divided by r squared, where F is the force of attraction between the bodies, m1 and m2 are the masses of the bodies, r is the distance between the centers of the two bodies, and g is the gravitational constant. This law is a direct application of calculus. From Earth to the stars, calculus is everywhere. So that was our tour around the world of calculus and its amazing real-world applications. We've delved into the 10 key aspects of calculus, and we've seen how it's not just a complex mathematical theory, but a tool that's used in a variety of fields. From predicting patterns in the stock market to modeling the growth of bacteria, calculus is a fundamental tool that helps us make sense of a complex world. This video is just the tip of the iceberg. There's so much more to explore and learn about calculus and its real-world implications. We encourage you to dive deeper, ask questions, and discover the fascinating world of calculus. Don't forget to support our channel by clicking on the links in the description. It's a simple way to help us continue creating content like this. Remember to subscribe, share, like, and comment. Thank you for joining us on this journey through the world of calculus.